Somewhere in northern China, a drone just took off on a test flight, and the material emmolding its wings together wasn't carbon fiber, wasn't aluminum, and definitely wasn't plastic. It was bamboo. Not decorative bamboo, not the kind you picture in a garden. Engineered, high-performance bamboo composite, strong enough to fly, cheap enough to mass produce, and grown fast enough to make plastic look genuinely outdated by comparison. If that sounds like a strange detail to build an entire story around, stick with this one, because what's happening across China right now with this material goes far beyond a single drone, and it might be the most realistic plastic replacement the world has seen in decades. And let's start with that drone, because it's the moment that actually caught global attention. Earlier this year, a bamboo-based tilt-rotor drone completed its maiden flight in Tianjin, and engineers involved in the project called it a genuine breakthrough for how bamboo composite materials can function in aviation. More than a quarter of the drone's entire fuselage was built from bamboo material, and the whole outer skin structure was crafted from high-performance bamboo composite developed specifically inside China. According to Qin Daochun, director of the International Center for Bamboo and Rattan, that level of bamboo integration in a fixed-wing drone had never been achieved anywhere in the world before this. Here's the part that should genuinely surprise you. This wasn't some fragile proof of concept built purely to prove a point and then quietly shelved. Compared with the lightweight, high-strength carbon fiber, the exact material aerospace engineers reach for when they need strength without excess weight, this bamboo composite reduced the drone's overall weight by more than 20%. And the cost difference is where this story stops sounding like a novelty and starts sounding like an actual industrial shift. Bamboo strips used in this application cost only about a quarter of what conventional carbon fiber fabric costs, lighter and dramatically cheaper at the same time. To understand why China specifically is the country pulling this off, you need to understand the sheer scale of raw material sitting right there waiting to be used. China holds the richest bamboo resources on the planet, with nearly 8 million hectares of bamboo forest, producing an annual output of 150 million tons of raw bamboo every single year. That's not a resource anyone needs to plant and wait decades for. Bamboo is famously one of the fastest growing plants on Earth. And unlike a tree that takes decades to reach maturity, bamboo can be harvested on a renewable cycle measured in just a few years, over and over again from the same root system. If you're finding this breakdown genuinely interesting, go ahead and hit that like button. It helps this kind of material science coverage reach more people who want to see where this technology is actually headed. This entire push didn't start with one drone flight. Back in November 2022, China and the International Bamboo and Rattan Organization jointly launched an initiative specifically focused on deepening global cooperation around replacing plastic with bamboo, aiming to leverage the material's natural strengths as a genuine substitute for plastic products across entire industries. Over the years since that initiative began, China's bamboo industry has expanded into something far bigger than most people outside the country ever hear about. The number of distinct bamboo product categories manufactured in China has now exceeded 15,000, and the industry's annual output value has surpassed 520 billion yuan, which works out to roughly $75 billion. That number alone tells you this stopped being a niche environmental experiment a long time ago. This is now a full industrial ecosystem, and the innovation happening inside it stretches into places you wouldn't necessarily expect. In Jiangxi province, one company has even engineered a functioning bamboo pipe organ, combining the traditional mechanical structure of a pipe organ with bamboo soundboards and resonance components, producing a genuinely clear, pleasing sound when struck with bamboo mallets. It's a strange example on the surface, but it reflects something important about where this materials engineering has actually reached. If bamboo composite can be precision-tuned for acoustic resonance in a musical instrument, the material science behind it has moved well past anything resembling a rough, rustic substitute material. The same company producing that pipe organ manufactures more than 1,500 different types of bamboo products, spanning structural materials for construction, decorative applications, and both indoor and outdoor furniture. And that diversity is exactly what's happening across the wider industry right now. Bamboo tableware and film bags are already in wide daily use. Bamboo grills and cooling tower packing materials are increasingly showing up in construction and industrial cooling systems. Bamboo fiber composites have been successfully integrated into automotive interiors. As a green, low-carbon, biodegradable material, bamboo is steadily becoming a genuine substitute, not just for plastic, but for steel in certain applications too. Now here's where this story moves from interesting to genuinely significant, because the most impressive engineering breakthrough in this entire push isn't the drone, and it isn't the pipe organ. It's underground, quite literally, running through trenches at construction sites across the country. In Sichuan province, engineers have laid bamboo wound composite pipes direct-to-Y into the ground as functioning infrastructure. According to Ye Ling, chairman of the company that developed this technology, their independently engineered bamboo winding composite process allows bamboo to be processed into large diameter pressure pipes, urban utility tunnels, and even components for high-speed train carriages. Think about what that actually means. This isn't bamboo being used decoratively or symbolically. This is bamboo composite carrying pressurized water, forming underground utility infrastructure and holding structural loads in transportation systems, roles traditionally reserved almost exclusively for steel, concrete, and heavy plastic piping. According to Ye, these bamboo wound materials are lightweight yet strong, offer both insulation and soundproofing, resist weathering and corrosion, and remain cost-effective and straightforward to install, all while being capable of replacing high energy consumption materials like steel and cement across a wide range of applications. The scale this has already reached is what makes it hard to dismiss as an isolated pilot project. These bamboo wound pipes have been installed across more than 700 kilometers of infrastructure, spanning 11 different provinces, while simultaneously increasing production efficiency by 25% and cutting unit costs by 13% compared to conventional materials. That's not a laboratory statistic. That's real infrastructure, already buried in the ground, already carrying real utility loads at a cost lower than the materials it's replacing. If this kind of material science and infrastructure innovation is exactly the type of content you come here for, go ahead and subscribe, because breakthroughs like this one tend to move from niche news into mainstream industry faster than most people expect. What's driving all of this beneath the surface is sustained, coordinated technological investment rather than one isolated invention. China's National Forestry and Grassland Administration has released 37 distinct key technological achievements, specifically related to using bamboo as a plastic substitute. These breakthroughs span an enormous range of applications, from sodium-ion battery, hard carbon anode, materials, an area directly relevant to next-generation energy storage, all the way through to high-end furniture design and fashion applications. New bamboo-based materials keep breaking past the traditional boundaries most people still associate with this plant. Across the broader value chain, China has been deliberately building out a comprehensive bamboo industry ecosystem, rather than leaving this innovation scattered and disconnected. Upstream, the focus is on cultivating large-scale bamboo producers capable of supplying raw material at genuine industrial volume. In the midstream, companies are strengthening core sectors like bamboo home products and bamboo fiber goods, while simultaneously developing emerging industries in bamboo-based pharmaceuticals, specialty chemicals, and bioenergy. Downstream, the material is increasingly integrated with tourism, wellness, and cultural industries, creating what regional planners describe as whole bamboo utilization models designed to extract value from every single part of the plant, rather than wasting any portion of the harvest. The regional economic impact of this shift is already substantial in specific parts of the country. In Nanping, in southeastern Fujian province, the total output value of the local bamboo industry exceeded 50 billion yuan last year alone. In Jingwen County in Sichuan, a bamboo-themed tourist destination built around the plant's cultural and ecological significance attracted 1.8 million visitors in just the first half of last year. Nationally, China now has more than 10,000 bamboo processing enterprises, collectively employing over 29 million people across the entire industrial chain, from raw cultivation through to advanced composite manufacturing. This industry isn't staying confined within China's own borders either. As the sector continues upgrading its technology and manufacturing capability, China has been actively promoting bamboo products, processing technology, and specialized equipment overseas, positioning bamboo as a genuine Chinese solution for the global effort to move away from plastic and reduce environmental damage. In Yuxi County in Fujian province, 280,000 mu of bamboo forest, equivalent to roughly 18,600 hectares, has received Forest Stewardship Council certification, an internationally recognized standard for responsible forest management. One local company built around that certified supply has developed eco-friendly tableware made entirely from bamboo fiber as a direct alternative to plastic products, and exports of that tableware rose 35% year over year. It's worth pausing here to actually understand why bamboo, out of every possible plant on Earth, turned out to be the material capable of pulling this off. Most people picture bamboo as a decorative garden plant, tall and thin and mostly ornamental. That picture massively undersells what bamboo actually is botanically. Bamboo isn't a tree at all. It's technically a grass, and it happens to be one of the fastest growing plants on the entire planet, with certain species capable of growing multiple feet in a single day under the right conditions. A forest of hardwood trees intended for construction lumber typically needs 20 to 60 years to mature to a harvestable size. Bamboo reaches full structural maturity in 3 to 5 years, and because it grows from an underground root system rather than requiring replanting after each harvest, the same plot of land can be harvested again and again indefinitely without ever needing to be cleared and regrown from scratch the way a timber plantation does. That difference in growth cycle is the entire foundation underneath everything else in this story. When engineers talk about a material being renewable, what they actually mean in practical terms is how quickly the supply can regenerate itself relative to how quickly it gets consumed. Steel and aluminum require energy, intensive mining, and smelting processes that release enormous amounts of carbon dioxide. Plastic is derived directly from petroleum, a finite fossil resource, extract 8D from deep underground. Bamboo, by comparison, pulls carbon dioxide out of the atmosphere as it grows, stores that carbon within its own fiber structure, and regenerates on a cycle short enough that an entire industrial supply chain can rely on continuous harvest without ever depleting the underlying resource. This is precisely why China's near monopoly on global bamboo forestry matters so much strategically. While bamboo grows across parts of South America, Africa, and Southeast Asia as well, no other country on Earth comes close to matching China's combination of raw growing area, established harvesting, infrastructure, and decades of accumulated processing expertise. That combination is exactly why the technological breakthroughs happening inside China's bamboo industry are translating into real industrial scale, so much faster than similar plastic alternative research happening elsewhere in the world. It's also worth putting this bamboo push into the wider context of everything else China has simultaneously been experimenting with to tackle the plastic problem from multiple directions at once, because bamboo composite isn't the only major material breakthrough coming out of the country this year. Researchers from the Shanghai Advanced Research Institute of the Chinese Academy of Sciences, working alongside Fudan University, recently proposed an entirely different approach. A chemical process capable of converting waste plastic directly into aviation fuel at remarkably low cost. More than 460 million tons of plastic gets produced globally every single year, and the vast majority of it ends up either incinerated, releasing pollutants into the atmosphere, or buried in landfills where IT can persist essentially unchanged for centuries. This new hydrogenolysis-based technique offers a potential third path, breaking down discarded plastic waste at the molecular level and converting it into usable jet fuel rather than letting it sit in a landfill indefinitely. To be fair to the science here, that particular breakthrough isn't a perfect solution on its own. Once the resulting fuel gets burned inside an aircraft engine, the carbon originally trapped inside that plastic still gets released back into the atmosphere as carbon dioxide, which is exactly why many scientists studying this technology view it as a complement to traditional recycling and waste reduction, rather than a complete replacement for cutting plastic production and consumption in the first place. Even so, if this process can eventually be scaled while keeping costs competitive with conventional jet fuel, it represents a genuinely useful tool for tackling one of the most persistent waste streams modern society produces, transforming yesterday's discarded packaging into tomorrow's usable energy, rather than letting it sit untouched in the ground. Alongside both the bamboo composite push and the plastic to fuel research, China has also been rapidly scaling up an entirely separate category of plastic alternative, biodegradable bioplastics, built from materials like polylactic acid and polybutylene adipate terephthalate, more commonly known by TER abbreviations PLA and PBAT. These aren't bamboo-based at all, but they're part of the exact same broader national strategy, using polymers that natural microbes can actually break down, so that a shopping bag, a drinking straw, or a sheet of agricultural mulch film eventually decomposes into water, carbon dioxide, and a small amount of harmless organic material rather than persisting in the environment, indefinitely the way conventional plastic does. PLA spun bond. Materials are already expanding into surprising new applications, replacing traditional nylon and polyester fabric in products like tea bags, compostable flower wraps, and gardening covers, along with cosmetic and personal care items like cotton pads and facial wipes. What all three of these approaches share, the bamboo composite revolution, the plastic to fuel conversion research, and the expanding biodegradable bioplastic sector, is a coordinated national strategy treating plastic pollution as a problem worth attacking from multiple angles simultaneously rather than betting everything on one single silver bullet solution. Some materials, like bamboo composite, are built to physically replace plastic and even steel in structural applications from the very beginning. Others, like the plastic to fuel conversion process, focus specifically on dealing with the enormous stockpile of plastic waste that already exists and isn't going anywhere on its own. And biodegradable bioplastics target the specific categories of single-use plastic products, bags, straws, packaging, where biodegradability matters. Most because these items get discarded within days or even hours of being manufactured. This multi-pronged approach is showing up prominently on the international stage as well. At China Plus, one of the world's largest plastics and rubber trade exhibitions, held annually in Shanghai and drawing over 4,600 exhibitors from dozens of countries, recent editions have increasingly centered on exactly this theme: environmental and carbon reduction technology, recycling innovation, and advancing bio-based and biodegradable materials as core priorities for the entire future direction, rather than treating sustainability as a niche side category separate from mainstream plastics manufacturing. So why does all of this actually matter beyond China's own domestic industry statistics? Plastic pollution remains one of the most persistent environmental problems on the planet, precisely because conventional plastic simply does not break down on any timescale EU that matters to a human lifetime, sitting in landfills, waterways, and oceans for centuries after it's discarded. Bamboo, by direct contrast, is naturally biodegradable, renewably harvested on cycles measured in years rather than decades, and, as this wave of Chinese engineering keeps demonstrating, increasingly capable of matching or beating plastic and even traditional structural materials on strength, weight, and cost simultaneously, rather than forcing a trade-off between environmental benefit and practical performance. That combination, genuine biodegradability paired with real industrial performance at a lower cost than the materials it replaces, is exactly what's been missing from most previous attempts at moving the world away from plastic. Plenty of alternative materials have existed for years that were more environmentally friendly than plastic on paper, but most of them were either too expensive to scale, too weak for demanding structural applications, or too difficult to manufacture at the volume modern industry actually requires. What's happening with bamboo composite in China right now looks different, specifically because it's clearing L3 of those hurdles at once, in infrastructure that's already buried in the ground, in a drone that's already flown, and in an industry already generating tens of billions of dollars in annual output. There's also a manufacturing angle to this story that rarely gets discussed outside industry circles, and it helps explain why bamboo composite is scaling so much faster than most previous plastic alternatives. Setting up an entirely new manufacturing process from scratch is enormously expensive, which is exactly why so many promising sustainable materials over the PA few decades never made it past small pilot factories. Bamboo processing sidesteps a lot of that barrier because China already had a mature, established bamboo harvesting and processing industry in place long before this current wave of composite engineering began. Traditional bamboo furniture makers, flooring manufacturers, and paper producers already understood how to harvest, treat, and process raw bamboo at industrial scale. The recent innovation has largely been about resin infusion techniques and precision manufacturing to an existing supply chain rather than building an entirely new industry from the ground up. That's a significant part of why this technology has moved from laboratory research to buried infrastructure and flying drones in a matter of a few short years, rather than the decade or more. It typically takes a genuinely new material to reach real-world deployment. It's also worth acknowledging the challenges this industry still faces before anyone gets too far ahead of the current reality. Bamboo composite manufacturing, like any advanced material process, still requires resin and binding agents to achieve the strength and durability needed for structural applications, and not every version of that binding process S is equally environmentally friendly. Researchers and manufacturers are actively working to develop lower impact resin systems specifically for bamboo composites, since the ultimate environmental value of the S material depends heavily on getting that part of the process right alongside the raw bamboo itself. Quality control across an industry this large and this fast-growing also remains an ongoing challenge, since more than 10,000 separate processing enterprises operating across the country inevitably vary in the consistency and quality of what they produce, which is part of why national-level technical standards and certification programs have become such an active area of policy focus alongside the manufacturing breakthroughs themselves. Even accounting for those remaining challenges, the trajectory here is difficult to ignore. A material that most of the world still associates almost exclusively with garden fencing and cheap furniture is now flying in aircraft components, carrying pressurized water underground across 11 provinces, and forming structural elements in high-speed rail carriages, all while costing meaningfully less than the materials it's replacing. That combination of falling cost, rising performance, and genuine environmental benefit is exactly the pattern that has historically preceded major shifts in which materials and entire industry decides to build around, the same pattern that once took steel from a novelty metal to the default choice for global construction, and took plastic itself from a laboratory curiosity to the most ubiquitous material on the planet within a single generation. None of this means plastic disappears overnight. And no single material, however promising, replaces an entire global industry built around petroleum-based plastics in the space of a few years. But what China has BAWILT here is no longer a small-scale environmental experiment running quietly in the background. It's a genuine industrial ecosystem, backed by dozens of distinct technological breakthroughs, already producing pressurized pipes, carrying real utility loads, aircraft components that have actually flown, and export products reaching international markets at rapidly increasing volume. If bamboo composite continues scaling at the pace it's currently moving, the material sitting in that Tianjin drone's wings and buried beneath those Sichuan streets may end up being remembered as the moment the world's plastic replacement finally stopped being theoretical and started being real, poured into the ground, built into the sky, and grown back again in just a few short years, ready to be harvested all over again.